All right, okay. Bye.
Hi, folks. We started a couple of minutes early just to get Mr. Paterson online. He's over in Aberdeen, Scotland. So we'll wait for 4 minutes for the scheduled time to start to allow all of our guests to join in. So just bear with us for the next 3 minutes, and then we'll get on with the webinar. Morning, folks. Thanks for joining us. Good morning in North America. I know we also have some guests from Europe joining, so good afternoon to everyone from overseas. Thanks again for joining another one of our webinars this week. And today we are going to be presenting you on Quickflange weldless technology. And my name, if I can click to the next slide. There we go. My name is Don Cooper. I'm the CEO and founder of Innovator Industrial Services. Innovator has been a leader in specialty industrial services in Canada for the last 11 years. We're happy to have celebrated our 8th year with a total recordable injury rate of 0.0. So we've had 8 years with a total recordable injury rate trending at 0.0. No injuries since May 12th, 2012 was our last recordable injury. And a lot of that focus in our business has been on innovation and technology, innovation and safety, and innovation in a variety of different service technologies. One of those technologies is a partnership we have with ICR Quickflange out of Aberdeen, Scotland. And today I have a good friend and colleague of mine, Phil Paterson. Phil is the international sales leader for ICR, focused on all their technologies, but Phil specializes in Quickflange. And Phil and I have been working together for a long time now. Phil, why don't you tell our guests a little bit about yourself?
Yeah, thanks, Don. Yeah, as Don said, Phil Paterson. I focus predominantly on the repair side of the ICR business, but I've been with Quickflange, predominantly the Quickflange part of the business, coming up for 11 years now. So I've seen the business grow from what was a fairly young and new business into what is now a global international business, which I'm looking forward to kind of exposing you to today.
Let's just jump into the agenda a little bit, folks, and thanks for that introduction, Phil. So for today's agenda, we're going to be sharing with you what is Quickflange. Some of you, I know some of the guests on here we've worked with a little bit in the past with Quickflange solutions. Many of you, this may be the first time and may have not even heard of a weldless connection, a weldless line connection before. We're going to share with you how it works, the physical aspects of how this technology works and why it is so robust and so safe. We're going to share with you how you can leverage it to eliminate hot work and create a lot of value for yourself in your facilities or for your clients if you're a general contractor, particularly in today's environment where we certainly have challenges around cost and schedule and our operator clients' ability to actually spend money on maintenance and repair. We're going to show you how Quickflange is tested and approved. We're going to go into how much time can be saved using Quickflange over traditional hot work welding. And we're going to let you know how you can get started and how you can leverage it in terms of where do you start with Quickflange and the ways that you can put it to use. What are your first steps? So what I need from each of you today as guests is just to be engaged and to participate. So one of the first things I'd ask everyone to do is to go into the chat section on the webinar and simply tell us where you're from and how long you have been involved in piping repairs, modifications, and the related hot work that happens with this. So the other thing that I'll ask after you all participate in just making a couple of comments on where you are and how many years you've been in piping. Throughout the presentation, please write down and be prepared to ask questions. At the very end, we're going to have a Q&A section. Some of you may not have used Zoom in the past. Or you've used it in a meeting function where you're interacting. The way a webinar works is it's very much a monologue between myself and Phil while we're presenting. And then at the end, we'll have a Q&A section where you'll be able to enter your questions, and then we'll do our best to answer those questions. But while Phil is presenting in the middle of the presentation, I'll also be monitoring the chat section that you're using right now. So feel free to make comments and participate along the way. And throughout the presentation, I'll be asking some questions on particular slides. So please to keep yourself involved. Just jump in on chat whenever you see fit. And finally, stay till the end. We will be sharing some links for you to get some additional information that you can take away for yourself and to share with your team. So don't leave if you'd like to get a little bit more of that information. So I'm just going to give you all another second or two. I see we've got about 10 or 15 people who've commented in chat. So I see lots of familiar names on here. I see Peter. How you doing, Peter? Up there in Taylor, BC. I see Richard Cleveland. Richard Cleveland. How you doing, Richard? Nice to see everyone joining. So let's get on with the show. So what are the kinds of challenges that you face that might be relevant for you considering Quickflange? Often, you know, I've gotten a lot of feedback from contacts and clients over the last couple of days who said, "Oh, I'm familiar with Quickflange, Don. I'm not sure if I need to join." And often those people have used Quickflange in ways, as an example, before we had CRNs and all the Canada-wide CRN approval. So there's a lot of places that you can use Quickflange today in Canada that you might not have been able to in the past. So some of the challenges you're going to face in today's environment that where you really want to think about how Quickflange could help is you're faced with time and cost associated performing hot work, particularly in today's environment. The next area is, you know, we have a lot of clients who have had to delay their shutdowns and their turnarounds, or the shutdowns and turnarounds that they're going to perform in the next 12 months or so have got reduced schedules and reduced budgets. And now you need to find new ways to be cost effective and potentially even remove certain tie-ins from outside of the turnaround event. And Quickflange is a way that can allow you to do that. Certainly, Quickflange eliminates 100% of the weld repairs that you might face across your project, because in this case, there is no welding. Another area that you may face that you want to consider for leveraging Quickflange is in difficult difficult materials welding, or if you have just a variety of challenges relative to welding, whether that's porosity or you've got a variety of vapors that are causing welding problems. And I've seen this even on carbon steel on something as simple as a P1 weld and just getting some passing vapor that was causing a lot of welding issues, and Quickflange could have solved that. So there's a lot of interesting use cases. Limitations created by weld location or weld position. We've done a lot of Quickflange work in tailings ponds or on barges where the welding position and the welding locations were just challenging. You know, and when you know, in the offshore market, sometimes we have used Quickflange in places where you have to install a flange with off ropes, and obviously welding off of ropes versus using mechanical equipment is a variety of ways that you can think about considering this. The other place is about, you know, if you watched my webinar on our turnaround optimizer process a few weeks ago, a big part of that is integrated crews and how do we optimize the number of people at the work face. And Quickflange is a great way to drive productivity by reducing the number of crews that interface at a particular tie point and really drive productivity. And I'm going to show you a few examples at the very end how we've been able to do turnkey tie points with Quickflange as part of the solution with just a very small one person and two-person crew. And just anywhere where you've got a lot of welding to do and you've got a tight critical path. We'll show you an example at the end on a SAGD facility where we took the welding of 30 flanges out of the critical path. It was a part of their 3-week, and it was a confined space job. We removed that from the critical path, and we were able to perform all those. We replaced welding with Quickflange, and we were able to do that work in 2.5 shifts as opposed to the 3 weeks that was planned. So there's a lot of great places that people may not consider using this. So Phil, I'm going to turn it over to you, and I'll be your sensei and guide the slides while you guide people through your technology. Over to you, my friend. I'm going to turn off my video to save bandwidth, and I'll jump back on later in the presentation, but I'll be here on audio.
Okay, thanks, Don. I mean, you've probably given a pretty good overview already just there, so maybe even stolen some of my thunder throughout, but no, that's good. No, listen, joking apart, everybody, thank you very much for attending and listening to Don and I today. So just to get started, I guess, I should give you a little bit of history on Quickflange. How did we evolve? How did we get to where we are today? So just to start at the very beginning, the concept of Quickflange really started in 2003. It was a Norwegian product of origin. So from 2003, when the concept was really born, it was 2004 before we actually did our first onshore installation. But what's really key to say here about the technology is that from the very get-go of the product, we were very strongly supported by Norway's national oil company. Without saying names, I guess we know who that probably is. But they saw the features and benefits of this product, and they actually helped us in the design, features, and actually the testing. So they actually took it to their market. So really the very beginning of the Quickflange business was evolved around the Norwegian sector. And it was only then we kind of started branching out from Norway. In 2008, we opened our Aberdeen office where I'm ultimately based. And then from there, we started getting partnerships around the world. But it was in 2014 when I guess some of the biggest changes for Quickflange happened when ICR bought over the product. And this actually allowed us to take the product to a global market and gave us the resources to do that. So in essence, that's a little bit of in a snapshot, a bit of the kind of history of Quickflange on how we came to it. So I guess if we move to the next slide, it's kind of what is Quickflange, I guess is the question. Just on the next slide, Don. And this is probably the power statement. This is the one that really tells you what it is. Well, it's a permanent means of joining a flange to pipe without the need to weld. And ultimately, any welded flanges that you would have normally used as your traditional weld nut flange, we're here to give you an additional solution instead of the traditional hot work. Now, Don has talked about a few of the issues you may have with hot work, which we'll go into a little bit later on. And I guess the key word here is permanent, because for any of you out there that actually are familiar with mechanical connectors, not all mechanical connectors are deemed as permanent. So they quite often are not. They can be deemed as a temporary fix. So Quickflange is approved as a permanent connection. So if we just move on to the concept and the installation process. So where a lot of mechanical connectors, again, if you're familiar with mechanical connectors, they can be quite an alien type of fitting. They're not something that you would recognize maybe as a flange or whatever the connector, a coupling or whatever. But with Quickflange, the way that the product is so simple is that we actually take a standard weld neck flange in many cases, and we simply modify it. So if you can see there on the circular image there, what we do is we machine down partially the neck of the flange and then the internal bore. Now the technology ultimately lies within the groove design. So you can make out there that there are some grooves machined into the flange. This is where we're going to use the pipe and a hydraulic tool to put a radial force into the pipe itself to swage that pipe into these grooves, creating a metal-to-metal gas-tight seal. Now, what's really key here is that the metal-to-metal seal, there's no elastomers, there's no polymers, so there's no degradation of the actual connection that you're going to make on the joint. And it's very simplistic. It's the technology that we're using ultimately is that, again, many of you will be aware of, it's almost adapting the boiler tube rolling that has been around for decades and hundreds of years. We've taken that technology and we've adapted it into the actual flange here. So once we've made up this connection, you then have an equivalent in strength and integrity to a welded connection. And I'll demonstrate that a little bit later on in some of the testing that we've done in order to get to that statements. But the business models is really quite straightforward. We sell the flanges to the client. So in this examples, Innovator would sell you the flanges. We then rent the equipment to go out and do the installations of that process. Now, with Innovator, of course, with the capabilities that Innovator have, that they will be giving you technicians that can do the cold cut. They'll do the preparation by cold methods, whether that be bristle blasters, needle guns, etc. And all we're looking for is a hand prep. Mechanical prep to the pipe is ideal, but a hand prep finishing off with likes of emery paper is all we're looking for on an installation of a Quickflange. So these guys can offer that. So every single step of the installation is 100% cold, from the cut to the installation to the hydro test. Now I'll move into a bit of the testing afterwards, but what's really key as well is that there are no welds to the whole manufacture process. That might sound a little bit strange to make that statement, but in some mechanical connectors, and of course welding is what we try to adhere to, some mechanical connectors have welded components. We have no welding at all. So what you can see here, this is a video we're going to play here. I'm going to try and run the video here for you. So this flange literally slides on, so in essence like a slip-on flange. Slide the flange onto the pipe, you do your bolt hole alignment as you would a weld neck flange, and then you activate the hydraulic tool. What you can see here is the cone pushing out, flaring out the segments with the ridges. It's these ridges that's doing the deformation of the pipe, creating that metal-to-metal seal. Now, the video you've seen does look very simplistic, and it ultimately is. That's how simple the process is. The biggest amount of time generally in a Quickflange installation is the pipe preparation. So what we're looking for, as I mentioned, is a square cut, a pipe cleanliness. So we're looking to ensure that there's no severe pitting or longitudinal or axial gouges in the pipe. And then you would do your activation and finish off with an emery paper finish. Now, there is one procedure you're not seeing on this video, and that's a Belzona procedure. Now, I'm sure probably a lot of you are familiar with Belzona, but just to talk you through it, we use Belzona 1111 as a product. That product is a two-part epoxy compound. It's a metallic compound once it's hardened. It's a machinable compound. We use this, and we use it purely and only at the neck area of the flange as a crevice corrosion barrier, because I'm sure there's many of you possibly already looked at this demo and wondered, is there potential for crevice corrosion? Absolutely. So this is why we use Belzona 1111 as a product, to prevent that at the neck area of the flange. Now, Don, if you could maybe just go back one slide for me, just back to the previous one before the video. There is also a small lip on the inner front of the flange. You can't necessarily see it on the circular image, but where we do the cut of the pipe and the installation of the flange, there's a small lip on the flange. We also put Belzona in that area, and it is the smallest amount, but what that will do is prevent any crevice corrosion from that first seal. Now, this image that you're seeing here is a two-groove solution. We have multiple different designs based on material and the application it's going to be used on, which we'll talk about later on. But in this particular scenario, you have 4 metal-to-metal seals in a two-groove solution. And I have an image later on that we'll run through. Don, if you can just now jump onto the range. So, in essence, what do we cover? And I guess that's the biggest question, because in most cases, the product range is critical to your asset. So it's 3/4 inch through to 14 inch pipework. Now, the wall thickness of pipe that we can deal with is 2 millimeters to 14. So up to 1/2 inch ultimately of wall thickness. Now, if we break that down, and I'll come to it in the next slide, but we are limited really on wall thickness. That's the biggest limitation factor with Quickflange as a product. It's not necessarily the pipe size, although we are currently up to 14 inch. We could go higher, but because we're using a hydraulic tool here to do the deformation of the pipe into the pre-machined grooves, you can imagine the power that we need to generate with that hydraulic cylinder. So right now it's 14 millimeters of wall thickness. That ultimately equates to up to shed 80 on some of the larger bore and schedule 160 on smaller bore up to say 4-inch. Pressure ratings, well, I mean, our mainstream is 150, 300 pound for sure is where our biggest window of opportunity that we have found over the last 16 years. However, clients have driven the products into the 600 and 900 pound range, and we have no issue with the qualification of these products, because what I didn't mention earlier, still in Norway is our engineering base for Quickflange, where we have an R&D department. And it is literally just a few months ago, we have just qualified a 1,500 pound connector for a client in the US. So if for some reason we don't have that connector approved within our range, it's generally because it's in either higher pressure or in an exotic material. But ultimately, we have the ability to qualify that product. So materials.
Couple of questions here, Phil, that came in that I'd like to answer on this slide. And I know the answers to this, but it's for the audience. Old pipe, out of round pipe, what's the sensitivity?
It's a great question, because the ultimately, when we started this business, we built the business in the offshore market. Now, if anybody's familiar with the North Sea, the severe conditions and that we work in, and the highly corrosive nature of the North Sea, it's predominantly heavily corroded pipe. So we have a huge amount of tolerance to work on heavily corroded pipe. Of course, we have limitations, but I can go into those with you. We've actually got a document I can share with you that highlights where we have our limitations. But ultimately, there's a wide window of opportunity where you can use Quickflange. Ovality, yeah, absolutely. We can deal with out of ovality. So any pipe that's out of it has some ovality issues, we can actually address those during the installation of the Quickflange. And without going into too much detail now, there's ways and there's procedures that we can take the ovality out using the tool prior to actually putting the flange onto the pipe. So to answer the question, yeah, absolutely, we can deal with that. And we have a wide tolerance to work with it.
And other type, you're about to talk about materials here in a second, Phil, so I'll let you cover that, and then I've got a follow-up question on materials.
Absolutely. Okay, so the materials, let's just quickly cover those then. I guess it's pretty obvious. By looking at the slide, we pretty much cover the wide range. Now, I say it's obvious, but maybe it's not in some of in mechanical connectors. I know there's limitations with some mechanical connectors, but based on our technology, we do carbon steel, which covers ultimately A105N and A350 LF2, so the low temp carbon steel. And in majority of cases with carbon steel, all our flanges are dual certified. So if you go back to thinking about what I was saying earlier with regards to how we manufacture them, it's an off-the-shelf product. This is a standard well neck flange that we modify. Now we have hundreds, if not thousands of these on the shelf, machines ready to go. So it's a very, very quick turnaround. When it comes to exotics, sometimes we keep a good stock of them, but they're the ones that might give you a bit more lead time. But as you can see, we cover duplex, super duplex, Manel, 6MO, and again in stainless 316, they're dual certified for 316 and 316L. We also do copper nickel, which is again heavily used in the offshore industry, certainly here in the North Sea for example, firewater lines, etc. And our flange geometry. So on you go. Sorry, on you go, John.
Yeah, sorry, just on the material side, you answered the 316L. Other stainless materials, if they're available in a standard flange, 304, 307, if you can buy the flange, effectively, we have the ability to take our design and apply it to those flanges, right?
Absolutely. So we have actually manufactured from F321 stainless, which has elements of titanium in it. So it's just
we do that
different compounds.
We did one of those in Newfoundland on a last-minute basis a few years ago, didn't we?
100%, yeah, absolutely. So it's not the most common. Obviously, 316 is very common in stainless, but we have the ability to adapt the technology. Now, if it's something that we haven't even looked at and never touched before, then it will go through our full mechanical process for qualification, which, as I said earlier, we have the ability to do, and we do on a regular basis. So, clients are always challenging us for new product, and whether it be higher pressure ratings or different materials. So again, as I say, we have the ability to qualify if it's not within our range. Now, in the next slide, really, we're going to go into a little bit more detail about the range, actually. If we could maybe move to the next slide, Don. This slide is a bit twofold. So this slide, in essence, is what I would call an off-the-shelf product range. This is qualified and ready to ship. In many cases, if Don doesn't have it in stock, then it'll be sitting in either our Houston facility here in the UK or Norway. So this is what we would call and deem our off-the-shelf product. But also, this is the size range that our training. So what I didn't mention earlier as part of our business model is that we can actually train third-party technicians to do this installation. Now, of course, for the onshore Canada market, Innovator is your go-to, and their guys will ultimately be the team that will come out and install these. But if you have a large shutdown, a large campaign coming up, and you want to get your core crews trained, then we have that training model in place. Now, if they were to be trained, this is what they could install. 1 to 8 inch, predominantly from the carbon steel range and the conifer range, and then stainless, 1 to 8 inch. And then when we move into the exotics, it's 1 to 6 inch. Now, you may ask, why is it not up to 8 inch? Because some of the range, we can't do the full size range in some of the exotics. So it's limited to 6 inch in this particular area. But what you can also see is the compatibility for the pipe schedules that we cover within these size ranges as well. And then the pipe compatibility. So whether it be A106 when it comes to carbon steel or A333 grade 6. But when we move into 8 inch and above, we may even have triple certified, as you can see there, which will have API X52 pipe. This slide here that we're moving on to is what we call our extended range, which takes us up to the 14-inch range. Now, this, and excuse the wording, but we've got ICR technician. When we talk about ICR, we treat Innovator as an extension to ICR as our partner. So it would be, we'd have these guys trained up to be able to do up to the 12, 14-inch installations. It's not to say that we won't allow third parties to do this, but in order for us to train them, we want to see them build up a bit of history, a bit of experience with some of the smaller tools before we move into the larger range. Now, on this slide, as per the last one, the limitations, and I think it's important to talk about the limitations because I'm not sitting here to say, Quickflange is the be-all and end-all for all flange replacement now, because of course, as a mechanical connector, we have our own limitations and the approval bodies have limitations. So let's just quickly cover that to get it out there. So category M fluid service, so toxic fluid services then is a no. We won't actually put a Quickflange connector on a category M fluid service. Hydrocarbon gas applications, absolutely, we will apply Quickflanges on hydrocarbon gas applications, and we have many, many times. However, we take it on a case-by-case basis with the hydrocarbon. So if it's a sour service, we will want to know in the parts per million within the sour service. We'll want to know a bit more in detail regards to hydrocarbon gas application before we will flat approve it for use. Now, as I say, the other main thing around hydrocarbon gas that we need to consider is this is not necessarily a standard weld neck. What I didn't talk about earlier is in hydrocarbon gas applications, we take a very conservative approach on this. And we actually put a 3-groove design into hydrocarbon gas applications in some of our from 4 inch and above. And in order to do that, you need to make that from a custom forging. So these can add lead time. So this is not what we call an off-the-shelf product. So if you're planning a turnaround or a shutdown, and we've got a number of weeks to get that. So So it's just important to put that out there. But as you can see, the off-the-shelf product is still fairly sizable. Okay, Don. Okay, so what we will do for everybody that's on the call as a part of a follow-up, when we're not in COVID-19, we would actually come to your office, and when we do the presentation, we'd actually do a live demo for you in your office environment where we'd actually make up a connector. So what we will want to do is reach out to you all and come and do that at some point. But this, in essence, is what we do to the connector. So if we were to cross-section any of our makeup of our flanges, this is what it would look like if it was a 2-groove solution. Now, simply, if it was a single groove, we would have 2 metal-to-metal seals. If it's a 3-groove, it's 6. I guess very, very simplistic. But how does it work? Well, ultimately, we're taking the 2 pieces of material, whether it be the flange and the pipe, and we're plastically deforming it. So we're working on the elasticity of the 2 materials. Now, what you can see in the deformation there of the pipe, where we've actually pushed it into the groove, the pipe is ultimately trying to straighten back out. That's it. It's working. It's the molecules in the material is trying to straighten back out, and we have ever so slightly dilated that flange where it's clamping back down on the pipe. So ultimately, the weakest component of this connection is the pipe itself. Now, under a bend and torsion or axial load, what will happen is the pipe will start to twist and give up before the actual connection from the metal-to-metal seals. Now, this is a good example actually on here to show you the Belzona. Now, if Don can just put his cursor up right next to the neck area of the flange, you can see where the potential of the Belzona, or if we didn't put Belzona, the ingress of fluids could go to that top seal at the neck area. But then at the actual raised face section of the flange, you can only just make out the lip. Just in there, that's where we would also put that bead of Belzona that we talked about earlier. That will prevent any crevice corrosion to any of the sealing points. But there is a huge amount of redundancy built into this connectors, having 4 metal-to-metal seals. So even if the primary seal gave up, you still then have 3 redundant seals, or you then move to the next primary seal and 2 redundant seals. So huge amounts of safety factor are built into any Quickflange connector. Okay. So how do we evaluate every application that you want to use it on? Because what we're not saying here, and this is how we want to protect you as the client, and also I guess ourselves and the technology, is that we're not going to give you a batch of connectors and say, right, off you go, just go and fire these on anywhere. We want to take a controlled approach on this, and this is what we've done from day one with Quickflange, is that we will, as the engineering teams, will request you to fill out an application form. Now, it's very basic information that you can make out, and apologize, it is fairly clear. I hope you can make out the detail, but ultimately what we're looking for is, first of all, what's the pipe details? What are you installing on? What's the nominal bore and actually the size of the pipe? What's the pipe measurement, the OD of the pipe if you have that? But what's the schedule? What's the schedule of pipe? Is that schedule 10, 20, 30, 40, 80, whatever it may be? And then the wall thickness. Now, you won't always have the wall thickness, we appreciate, but if you have a UT check, which again, in a majority of cases, unless it's a real emergency repair, you'll probably do a number of wall thickness checks before you do your spool replacements. If you have that, by all means, please pass it on. And then what's the standard and grade of material? Sorry, Don, you can just go back one for me.
Apologize.
There we go. That's all right. And then the flange details, because what we want to make sure is that we're mating up the correct material with the correct material, so the flange. So we will not cross-contaminate materials. And I know that ultimately you won't do that either as operators, but we have been asked, when it's maybe going to be a very temporary repair, maybe for a short period of time on a decommissioned line, can they put a carbon steel flange on a stainless steel pipe just to save some cost? We wouldn't do that, because that's not the right business practice to do. And of course, if there is galvanic reaction, etc., as you know, that can happen. And we only test on mating materials. So all our testing is based on mating materials for flange and pipe. So we will ask you the information. Is it an ASME flange? Is it the GIS or EEMUA standard? What's the material? Is it A105? Is it A350 LF2? Whatever. You get the picture. But when we start moving into the application details, this is really quite critical, because this is where our engineering team, once they review this form, will then decide what flange are we going to give you to do this install. So if you cast your mind back a couple of slides when we talked about hydrocarbon gas, well, this is where you're going to highlight that. What's the service process? You know, is it hydrocarbon, is it gas, or is it liquid? Is it sour service? Is it category M? And then on the line details, if those answers are acceptable, the line details are also critical around the design. What's the temperature you're going to be of the design of that line, and what's the operating temperature, minimum, maximum? Same with the pressures. And then is there any severe cyclic conditions to the line? You know, whether it be vibration, or is it temperature fluctuation? You know, so we'd just like to know these up front. And then there's a nice to know information at the bottom. Is it, you know, what's the pipe orientation? Is it confined space, etc., etc. So I've spoken a lot on here, but it's an important form for us to review, because, as I say, it ensures that we supply the right connector for the application you want to use it on. What you don't see on this form is that at the bottom section, there's a section where our engineering team sign off and put down the drawing numbers for the flanges and the tools that we'll use for that. And that then will indicate, is it one that's going to be manufactured from a custom forging, or just an off-the-shelf product? And this has the lead times. This thing gets returned back to you, and then you have that information. So that's pre-job planning and pre-job instruction, which again you all do, whether it be for a repair scope or a shutdown or turnaround. This is just the information that we gather up front. Now, what do we do post-installation or during the installation? So how do we protect the technician, the client, and us? Again, this is a bit now the part of the QA/QC. This is called a job verification document. We commonly refer to as the JVD, and this is completed for each and every Quickflange installation. Now, we have over 10,000 plus Quickflanges installed around the world, and ultimately, we can tell you who's installed them, but more importantly, where have they been installed? What was the line number? What was the condition of the line that they were installed on? So if you were to come to me in 4, 5, 6 years time and say, Phil, can you just tell me, you know, ultimately we have an idea, but can you tell me where we have all our Quickflanges installed on the site? Then I can pull a list very, very quickly down to the actual line number. But more importantly, I can even give you the serial number of the flange that you installed, because every single Quickflange is uniquely serial numbered. They all come with their original heat certs and heat numbers from the original mill certs. So that's the traceability section. But what about the accountability and the safety net for the technician installing? Well, as I say, there's a document for every single size schedule material for what we install. But what you can see just in the first or the second yellow box in red writing, you might not be able to make it up, but just where it says pump pressure, further up there, Don, just up a little bit there, you can see that says 430 bar of pressure. Whether it be metric or imperial, we have both documents. This tells the technician what pressure they must take that pump to activate the hydraulic tool. So there's no guesswork here. There is no charts that they need to read based on size, schedule, and material. And we're reducing the potential for human error. Also, in the larger yellow box, what we have there is the limitations of the wall thickness. So again, because we've asked for UT checks up earlier, we'll have checked those and gone, yeah, it's suitable for use. But sometimes we appreciate when you cut into a piece of pipe, you sometimes get a false reading off a UT. Now, that happens probably more often than not in a lot of cases, and we've come across it a number of times. What this does is it tells the technician to stop. If it falls out with these parameters, they stop the job and they will contact Innovator or Quick ICR, because we're all a 24/7 company, and we'll have somebody on the end of a phone that can talk them through the process. up until now, and as I said to you earlier on, I've been with the company for 11 years coming up. We've never left a client with an open-ended piece of pipe yet. We've always come up with a resolve. So there's ways and means, and whether it's increasing or decreasing pressure of the pump and what have you, orientation of the tool, etc., we can do that. Or even it could be that we actually manufacture a flange to suit your heavily reduced wall thickness, you know, so we can do that too. So then once it's all completed up, it's signed off by the technician, and then it's signed off by the supervisor on site. This then goes into your job pack or into your work pack. It also gets sent back to us at ICR, where we document and we file it for you. And ultimately, it's your warranty document for that connection. Okay, I don't know if I mean, maybe we'll get some questions later on that, but so approvals, well, approvals are pretty straightforward. And I guess because I mentioned earlier that we built this business in the offshore industry, so as you can see, we naturally have an ABS and a DMV type approval there. But certainly for Canada, which is absolutely critical, and we had to go through a number of hoops to get these CRNs. But as you can see there, we have CRNs Canada-wide. So there, I don't believe, and Don, you can correct me if I'm wrong, but I think we have one for every single province within Canada.
Every single province and every territory, Phil. So a couple of points, because we've had a few questions around QC and around data collection. And one, all the CRNs are registered to Innovator's quality programs across the country. So we started by getting TSSA approval, was actually our first jurisdiction, and then we followed with ABSA registration. And then generally the other 5 jurisdictions that cover all the other provinces and territories followed suit. The big thing, it took us about, I think 6 years to get CRNs, not because of any engineering challenges, but just the jurisdictions just didn't understand how this worked. And so we finally got to a place where we did proof testing on all of our applications. We used UG 101 proof testing and did destructive to failure tests on all the connections. And that was really important because it established the protocol, not just for getting our initial catalog of fittings registered, but it also established an acceptable protocol so that anytime we ever wish to register more designs and more materials, it's a seamless process now. All the jurisdictions know exactly how we're going to submit, and it streamlines the process to be very quickly. From a QC standpoint, because we're not just getting a CRN, they're registered under our quality program, we will develop an entire turnover package for you. So the same way that you would have a turnover package for a hot tap or a leak repair fitting, or for any welded connection, we will develop an ITP under our program. We will provide the CRNs, the MTRs, all the technician qualifications, the entire process. And when we're done with a connection, you get a full tie point turnover package that is registered in the jurisdiction that those fittings are installed in. So no different than any other tie point that you would do with traditional methods. You there, Phil? Not sure if everyone can hear me or not. I think we seem to have lost Phil there for a second. I'm going to wait a second to see if he picks up the line, and if not, I'll carry on. So we see a few questions here. I think Phil is trying to log back in here. This has been DNV approved. We have done some Lloyd's approval. I see a question there on Lloyd's, ABS. And the big thing with the qualifications is in each case, and we started this, or Quickflange started this with with DNV. And I think we've got Phil back there. We lost him for a minute, but I see him back on screen. Can you hear me now, Phil?
Yeah, I hear you. I had to go and put another $1 in the meter. No,
We're just talking about qualifications, Phil. I finished talking about what we've done in Canada. I was just about to dive into how Quickflange and ICR started with DNV to create the type approval process. Why don't you pick up from there?
Yeah, absolutely. So the DMV was like almost a two-stage approval process. So when we first got our first certificate from DMV, it was very much on a first phase where it was utilities. And then phase two is when we actually went into the hydrocarbons. Now, to be honest, it was a lot of the testing that we had to do in order to be for the CRNs actually aided the DMV for us with the, as you can see there, the proof testing, the UG 101, which is all the burst testing, is what actually supported us and with the type approval there. ABS was generated on the back of the requirement for a lot of our offshore FPSO work that we did and do on a regular basis, whether it be out of West Africa and Brazil and etc. So that was driven from there. But the amount of testing, we're actually going to cover a little bit about testing just in the next slide.
I got one question from one of our guests, Phil, and I can add a little bit about what we've done in Canada on this in the past, but we have a question around, is it Lloyd's register approved for offshore similar to DNV?
Yeah, it's exactly the same. So you either tend to go down the Lloyd's route or the DMV GL route. It's because we were a Norwegian company of origin. DMV was the natural route that they took. But you're absolutely right. So it's either in a lot of the offshore industry, either recognized as DMV or Lloyd's is what you go down. ABS is obviously more for the American Bureau of Shipping. So, yep.
I can't recall the FPSO, which one of them in offshore Newfoundland. One of them was Lloyd's, and I can't recall which one it was, but to get that approved by the client, the Lloyd's office in St. John's took our DNV package and reviewed it and effectively gave a approval for the installations that we're doing. They didn't do a full type catalog approval, but they very quickly, within a day or two of looking at the project, approved the applications. I can't recall if that was Hibernia. I think Hibernia started off as Lloyd's, so maybe it was Terra Nova. Oh, there's Paul Walsh. Hey, Paul. Yeah. So, and we've done several on Terra Nova with the client since then. So that's all. We've worked out all those processes. Just to be clear, Innovator isn't working in the offshore space anymore. We in Newfoundland, we're ICR is working with the Crosby Group to do that. Now. We got that process going for them and then handed that ball off because the Crosby Group had people there full time. But all the groundwork for DNV and Lloyd's in all of the offshore platforms in Atlantic Canada is all covered. Let's move on to testing now, Phil.
Yeah, absolutely.
I know Peter had some questions about vibration, and I think we've got a video we're going to show with some of the vibration testing. So
we absolutely do, and I'm not going to walk you through every test because that even I might fall asleep on that one. But what we do have is every single test data here is we're 100% transparent with all the test data, and we'll share any of it with you. Really, this slide is just a highlight, and I guess we kind of just covered it there on the previous slide regards the approval bodies as to the extent that we've had to go through to qualify Quickflange as a product, whether that be for the onshore market, whether it be the offshore, and various different industries. So but what I do want to highlight just now, though, is that although we have type approvals, and many type approvals allow you to test X and Z, and Y in the middle is automatically qualified because you cover that parameter. So in that scenario, that's not what we do. So we don't interpolate results or extrapolate numbers from previous tests. Every single size schedule, pressure rating, and material goes through full mechanical testing before it is allowed to be released for sale. So every single configuration within our range has its own test certificate. And again, if you are planning, or more importantly, when you are planning to use a Quickflange, I can issue those certificates up front, and the team at Innovator, with part of the documentation package, can give you those results to let you see what we have tested the connector to. Now, the question might be, well, how do we know what qualifies and what doesn't? Well, DMV, as our approval body, have taken the test and designed the test around either the code, ASME code, and ultimately what is required in order for the connector to qualify as approved connector. Now, I'm going to show you a slide after this, but before I get there, you can quickly see that we carry out gas or gas tests, we carry out axial load tests, bending moment, bend and torsion, and of course some of the tests that we've had to do are one-off tests, such as fatigue, corrosion testing. We've done vibration, and part of the vibration, we do vibration and pulsation testing, which I'm going to show you a video on just shortly. We do FEA analysis for new connectors, etc. So we have that ability, and that's what we do for every connector. But we've also gone sometimes what would be deemed as the extra mile. So some clients, where they accept the testing that we've done, have some of very, very specific tests, depending on maybe where they want to use the connector. We've actually carried those out. So for example, one of the great ones is the fire testing. So as we all know, flanges are not fire safe anyway, but the client wanted to use this on a fire header system and wanted to ensure how would a Quickflange connector respond or react under fire state. So we actually carried out an API 6FA valve fire test where we subjected to 750 degrees Celsius under flame for half an hour with a spool pressurized at 20 bar pressure. We did that both for carbon steel and copper nickel pipe with no failure. We then did cryogenic testing for another client who was wanting to use on a service, where we actually we just tested to do it at -100 on stainless steel. That's -100 degrees Celsius. And one client wanted it tested at 110. We did that test for them. So we have tested the product to -110 degrees Celsius. That said, though, we have limitations within our approval body. So, it's -46 degrees Celsius to 205 degrees Celsius. But what we've done is we've tested the product way and beyond its requirements. We've done sour service testing. I just want to highlight that, we've done excessive and extensive testing with this product. And it's unlikely, but hey, at the end of the day, if there's something that you need, then let us know in order for you to use the product. But the likelihood is that we'll have carried out a test or a very similar test for that. Now, if we move on to the next slide, Don. This is the video. So before we play this video, let me tell you how this came about. This is a bending, ultimately a bending and torsion, but it's a bending moment test. This was going to actually go on an FPSO off the west coast of Africa. Now, the client, although we've done bending and we do bending torsion tests as a standard test, what you will see on this test once we get it going is the severity of bending moment. So as Don was just highlighting there, that's the Quickflange at the end, and it's bolted to our it's about a 2-inch plate jig. And then we have another Quickflange up the far end here, at the near end with a blind. So it's a fully blinded Quickflange spool, and it's pressurized to 20 bar of pressure. Now, if we run the video, what you can see here, it's just maybe the streaming here, but you can see the bending moment and the severity. This went through tens of thousands of bending cycles with no failure. So this is ultimately as well giving you a stress intensification factor of that connector, which we can also do. So you can just see this the
I think
bending
the
moment
only
there
the
on how
only
much-
guest on here that's going to have fitting work that is that severe for bending moment is probably Paul Walsh. Hey, Paul.
Okay.
Kidding, Paul.
But I think what I want to highlight here is just the severity of the testing. And yeah, do you know what? I again, a bit of tongue in cheek, I guess, that if you are subjecting your pipe work to that much bending moment, you've got bigger issues than a quick flange leaking. And it's a really important factor because, in fact, I'll go on to my next statement, but we move to the next video actually, Don.
This will show. Peter had a question about vibration earlier, so I'd like you to speak about vibration a little bit.
Yeah. So this is an exceptionally quick video, so I don't know if we can put it on a loop at all there, Don. But anyway, let me just talk you through the setup that we have here. So first of all, you can see this is witnessed by Syntef, which is one of the major approval bodies. What we have is a dome-ended spool here, and the let's call it the gray, the silver flange is a quick flange. The gold one, which is just the coating, is actually a standard weld neck. Now, what you can see here, this is actually a custom forging because this is a little bit thicker than the traditional weld neck that it is bolted up to. But everything is designed to ASME B16.5 configuration. Now, this was a vibration and pulsation. So you can see it being held in the vibration jig. And then just on the top end, you can see a hose is going in and it's giving a pulsation. Now, I don't know if you could run the video again for me here, Don. So it's so quick. This went through in excess of 10 million vibration cycles and 500 pulsations.
All right.
Sorry, Don?
Keep going. Sorry, I jumped ahead there. I was trying to replay the video while you're speaking.
That's all right. No problem. This test actually went through, it took 5 days in total to do the test. It should have been done in 3. But actually, ironically, and this was not the design behind the test, but because this is actually hooked up to a weld neck flange, which is welded to a pipe held in the jig, the actual weld cracked twice during this test. So ironically, the weld gave up versus the quick flange. The quick flange had no failure to this. Now, actually, I mean, this video is struggling to kind of stream so well, but what we can do, we can actually share the link to this video to anybody that wants to see it. But as I say, I mean, we appreciate the weld neck was probably subject to a bit more load, but a very good test. But this is part of our type approval testing that we need to go through. So it has been tested for vibration, but not just vibration, but pulsation at the same time. The next slide actually gives you just a bit more of the mechanicals testing that we do. So what you can see here is this is typically an 8-inch. That's the same connector actually as what was in the vibration test. You can see the values there that we're subjected to under the bend and torsion. So whether it be 110 kilonewtons, but most importantly there to look at is it's 140% of ASME's requirement. So that's the key here. What we also have is the pool test, the actual load testing. This is 100 tons of pool with no failure. The reason why we always pool, we do actual test of failure, but on this particular scenario, our machine couldn't pull beyond 100 tons. So again, a little bit of tongue in cheek, if you're exposing your flanges or your piping to that amount of loads, then you've got bigger issues, I guess, than a quick flange leaking. But this is what I wanted to highlight, that what you will never have with a quick flange is a catastrophic failure, because even under an actual load test, all you will have is a loss of pressure, and it'll be a weep or a drip from the neck of the flange is all you'll get. As you can see on the burst testing here, the pipe, as I mentioned earlier, is the weakest component. Your pipe will let go before the actual flange connection. I mean, ultimately, whilst the flange is under pressure, I can't say it works better and it gives you more performance. That'd be wrong to say. But as the pipe is pushing into the flange and those pre-machined seals, it's never going to give up. Of course, it's not. But on the flip side, we've actually worked on vacuum systems, and so we kind of cover all bases. But as you can see there, the burst testing, every single time the pipe will let go, and that let go at 580 bar. I can assure you the test bay were a little bit concerned as that pressure was building. What was it going to let go at? So again, we go through this testing with all our connectors. So. All right, Don.
I have a question for just for the audience before we jump into the next slide, because we're going to talk about installation times versus weld times in a moment. And just to frame some reference, one of the big benefits outside of everything we've talked about with Quickflange is eliminating hot work. And so in the context of a turnaround or maintenance when you're in a live plant situation, I just want to ask the audience what you believe is the time and cost associated with getting ready for hot work versus the cost of the direct cost of doing the physical fitting and welding, just as a percentage. How much hot work preparation cost and time as a percentage of the total project is it compared to the actual final execution? Just throw in a percentage of what you think that is. Just do it, mention it in chat if you could, please. And we're going to move on while you're commenting and talk about the preparation for hot work versus actual. And we're going to talk about installation times. Go ahead, Phil.
Okay, so I'll throw a caveat right away just before I get going on this, because you're looking at this chart, and if I have any welders, or if we have any welders here, they're going to be spitting dust at this slide. But however, so I just want to put it out there. This is an offshore welding norms. These timings that we've taken on this chart. So I appreciate for an onshore market, it will be different. But regardless to your welding norms, as Don just asked that question earlier, there's so many inputs to a hot work that quite often that are not forgotten about, because that's the wrong term, but you do is because that's what you have to do in order to do a hot work. But these are the processes that we're saying that we're going to take out of that pain that you have, whether it be an admin pain or whether it is just the physical achieving a hot work. So let's take the basics. Think about a hot work. What's involved? So from the cut to the preparation. So let's even break that down. So it's not just as simple as doing a cut. You actually have to do a cut and bevel the pipe. That's a specialist tool, specialist person, potentially. You've then got any pre-heat treatments. You've then got the weld itself. You've then got the stress relief, potentially, and NDT requirements. But what we never think about is the rework. So we never take into consideration is how much rework time do you put into a weld when you have a weld failure? Now I appreciate that, weld failures are maybe, I don't know what that percentage is, but any rework is lost time, it's lost money. And again, I mention this in all my presentations, and it's a bit of tongue in cheek again, but with a Quickflange tool, is a hydraulic tool that's operated with somebody at the end of a pump. We're not influenced by weather. We're not influenced by necessarily, conditions or the human factor. Of course, there is a human on the end of the tool, but a Quickflange tool doesn't have a bad day. It's consistent every single time it's installed, So as long as that technician takes that pump to that pressure, you have a consistent install every time. Now, so, there may be questions out there or questions that are going to come in, and I don't want to preempt them, but the question would be, how many failures have Quickflange had? And I think it's really important to talk about failures, because for me to sit here and say we've never had a failure, well, that would be a flat out lie. Of course we have had failures, and that's how we learn our business and why we are where we are today. Now, but our failures are rectified generally because we haven't taken the pump to the right pressure. We have had a couple of installs where the technician has not cut the pipe square, and sometimes you can't accommodate and I'm going to say it, it's stupidity sometimes. I mean, you can train somebody as much as you can, but sometimes you just can't help somebody making a complete error. But what I'm saying to you is with Quickflange, it's consistent every single time. Our failure rate's at 0.02% over 10,000 connectors. So, you work that out, that's really not a lot of failures, because what we do is we do an inspection process. Now, let me just cover that quickly because we didn't talk about it earlier. But there's two ways of inspecting a Quickflange post-installation. Number one is a visual, and number two is a hydro test. Now, the hydro test, if you're going to have a Quickflange is going to leak, it's going to leak at the hydro test. If it doesn't leak at the hydro test, you have a permanent connection. It's not going to leak. But that's where we'd pick it up. And we've managed to rectify all our installs at the hydro test if there's been a leak. And generally, it's because the technician hasn't taken the pump to the right pressure. It's a simple reinsertion of the tool and off you go. But let's go back to welding. So we built the business, as I said earlier, in a very harsh environment in the North Sea. So we're used to the wet, windy, cold climates. Maybe not quite as cold as Canada, I'll give you that. But what we've done is we've exposed the product to huge amounts of elements. Now, if you do a weld in the same environment, you've got to have your habitats, and it could even be a pressurized habitat. And think about all these indirect costs sometimes that's involved with the hot work. This is where we say we're going to save you time and money. Now, that 80% time saving, even if we turn around and says, right, it's 40% time saving. 40% in any shutdown is worth a huge, huge amount of money. I mentioned earlier that we're not here to replace welding. We're in every case, we're absolutely not. But what if you could take out, 20, 30, or 40% of your flange welds and replace it with cold work and free up the welders to go and do the larger bore stuff or gratings or whatever it may be, and just increase your productivity within your shutdown by the 30, 40, 50%, and or reduce your shutdown time. What's that actually worth?
You're also eliminating the fire watches and all of the other associated costs that go along with that, right? Because now you're executing the entire project cold.
And that's the key for onshore and offshore as well for POB, the personnel on board. But on site, if you can reduce the amount of human exposure time to any job. So in a hot work, we hear and we get told it's anything between 6 and 10 or 12 people, depending on the size of the scope, to do a hot work. That might be from fire watch, from laborers, from riggers, etc., etc. With a Quickflange crew, we will come on site with ultimately a team of 2 that are trained to do the cut, the prep, the install, and the hydro test and bolt up. So when you talk about that kind of reduction of footprint and the reduction of human exposure, that's why the safety element is just so much higher and worth considering the use of a Quickflange versus a traditional hot work method. Okay, Don, I think
a couple of quick questions, Phil, before we jump to the next slide. So Peter has a question on how robust are the tools and how much maintenance is needed to maintain the quality of the installation Quickflange equipment.
Okay, I mean it's critical. Of course it is. It's critical, the maintenance of the tool, and that's why up until now we've never sold the equipment. It's on a rental basis. Now that rental basis can be short-term to actually just going out, doing the job and taking the tool back. We do mid-term, where if you're actually doing a turnaround and it's a 3, 4, 6 week turnaround, then you can rent the equipment to have it on site for that period. Or we can even do long-term. We do this for some of our clients where they actually have a 5-year contract and they have the equipment on the ground. Now, part of that is the reason why we don't sell it is because of the maintenance that's required. We train every technician that does an install how to do the routine maintenance, but it's absolutely critical that a tool is taken back to base and it's stripped down and reassembled and tested accordingly. But a Quickflange tool will do multiple installs before it needs to get to a strip down and rebuilt scenario. But there are routine maintenance we do, whether it's just greasing of the cone, replacing some O-rings if required. So it is, of course, it's like any tool, any equipment that you have in your toolbox. It's only as good as the tool you've maintained. So it is a critical point for sure.
Other question that you mentioned this earlier, but I just want you to repeat it. Deepak asked, if a leak does happen on a hydro test, how do they proceed?
Okay, so first of all, there's a few visual inspections you do, as I mentioned. First of all, and the hydro test, during the hydro test, if you have a leak from the Quickflange after install, we would reinsert the tool. So part of the procedure when we install a Quickflange is that we mark the flange, the pipe, and the tool. So if in the event we need to reinsert the tool, it goes in exactly the same position as it was when we originally installed the tool. So it just is a simple reinsertion of the tool and reactivate the tool to the correct pressure or to the required pressure for on the JVD, and that's the job verification document.
Great. Thanks,
And
Phil.
99 out of 100 times that will cover the issue. Now, I guess the scenarios, I'm not going to go through every one because I'm sure you know everybody out there can probably or hopefully can see the benefits where you can use it. But what I want to do before Don kind of goes into some of the case studies is just to take a moment and think about the scenarios that you have. When we built the business up from the beginning, and as I say, I started with the business 11 years ago, so we were still in the very early stages, and predominantly Quickflange was just used as a tie-in. So where you were going to cut out a section of pipe, you would prefabricate a spool, drop the spool in, and you would put 2 Quickflanges in as a tie-in piece, and off you go. But as we started developing the product, what we actually found was that clients were having more and more issues in the tie-in scenario on modification side, where, as I mentioned earlier, you know, you cut the pipe and you've got reduced wall and you're going to have to move the cut line, and then your spool doesn't fit. So what we actually now do is a lot of on-site spool fabrication. So it gives the client so much more flexibility to install their spools. And you can prefabricate elbows and T's, so you can actually cut them to size and then do the installation with a lot more flexibility. And then decommissioning. Decommissioning is a huge part of our business and is becoming a big part of our business in the North Sea for the offshore installations. But what we actually have done on onshore facilities is the amount of decommissioning, and it's temporary decommissioning. So where you're actually going to decommission a line because it's going to be out of service for 8, 10, 12 months or whatever it may be, you need to cut the line and put on a blind. Well, you've still got the same hot work restrictions. So decommissioning is a huge part of our business. And sometimes you don't think about that elements when it comes to likes our Quickflange or mechanical connector. So we have done on-site fabrications where, you know, we've done hundreds of meters of pipelines and where they've dropped down, maybe it could be instrument airlines, it could be drain lines where we've actually just dropped in and we've prefabricated whole lines. So is this a scenario that you'd use in an environment where you could do hot work, there's no time constraints, and you're in a facility where you know you don't have any of those issues? Of course, you're always going to go to the welding option. What we're saying here is with Quickflange is we can take a lot of the headache away on site when it comes to doing a lot of these repairs. So that kind of sums up the Quickflange product for me. But I think what we're going to do now is probably going to move into some of the case studies. There's a few real key case studies specifically in Canada where we saved huge amounts of safety elements, but probably there's a huge amount of savings, cost savings that we did, which Don's going to probably go into a bit more detail in.
I'll jump into those in a moment. I've just got 2 more quick questions I want to address. Deepak asked about any approvals for the nuclear industry from your perspective. I'll share our perspective on that. I'm not aware of what you may have done in that space or not, Phil.
So no, the answer to the question is we've not specifically gone into the nuclear industry. It is absolutely a market that we are looking at and believe there's a huge opportunity. Back down to human exposure time. So if we can reduce human exposure time in a nuclear facility, and do it a lot quicker and safely, then I think there's a huge opportunity there. But the actual accreditation or approvals, no, we don't have any specific for there, but we'd be interested if we need to look at that.
So Innovator has a nuclear qualified quality program in Ontario, and we've been audited by OPG. We've been working with Ontario Power Generation in both their Darlington and their Pickering nuclear power plants for about 8 years now. We are their sole on-stream leak repair provider, so we do a ton of leak repair design, custom design, and approvals, and go through that whole approval process. We haven't done Quickflange yet, but I don't see a whole lot of challenges. Particularly, the interesting thing about a nuclear power plant is that 95% of the pipe work and 95% of the work that we do in a nuclear power plant is actually on the conventional side and not on the hot side of the reactor. We do some hot work on the reactor side, but 95% of the work is actually on the conventional piping side. So we haven't gone down that path, but interestingly enough, there is a lot more openness to innovation in the nuclear industry in Canada this last couple of years. We've recently introduced engineered composite pipe repair into the nuclear power plants with great success and with a lot of open collaboration with the clients. So I don't see it being a game stopper. And your question specifically about using Belzona in a nuclear power plant, again, we haven't addressed that yet, but we can look at our procedures. The primary reason for Belzona is crevice corrosion, and it was designed around seawater entering into those areas. So we can look at any of those challenges, and we've got a really robust engineering team, and we've got a strong background in designing and getting registration and approval with TSSA in the nuclear industry. So haven't done it yet, but we'd certainly be up to the challenge, and we certainly have the right quality pedigree to do that.
Yeah, can I just add there that that's a very good point in regards to Belzona. Now, it is part of our standard installation procedure, but if you're in a particular facility, as you say, that you can't use it, and we don't deem as crevice corrosion, or is there an alternative that we need to look at, please let us know, and we can either eliminate the need for it because you believe that there is no risk of the crevice corrosion, or if you have an alternative product, because it does not create any sealing. When I talk about sealing, mechanical strength to the joint, it is just a sealing to stop the ingress of fluid. So we would absolutely listen to anything. So yeah, feel free to come back to us on that.
The other question that I have before I jump into 3 case studies is, Paul asked a question specifically about in the offshore market with compact flanges, whether that's a Secure Max or a tech type flange, compact type flanges. Have you ever done any work with installing those kinds of types of flanges? I know there is some custom stuff that you've done with Victaulic connectors. So you've done some quick flange installs of a Victaulic connector. So anything that you've done with any other kinds of offshore types of flange connectors that are different, or modifying a quick flange design to mate up with a different style of flange?
Yeah, not really. The answer to the question is ultimately no. We have different standards, obviously JIS flanges, the Japanese industry standard flanges, what have you. But ultimately, no. We most of our connectors, 90% are all for a standard. The mating flange must be as per the same flange, which ultimately is as the ASME B16.5 flange. So we can mate to ultimately anything, but we haven't modified anything other than your standard ASME flanges.
Thanks,
ultimately, is the answer to the question.
Well, let's dive into some of the applications that we've done. Plenty offshore, but we've also done some really fun and interesting applications onshore in a variety of places that you might not expect. So I'm going to share the first. This is actually the very first quick flanges that we've performed in Canada. So in this situation, what we have is a SAGD client in the Cold Lake region here in Alberta, who had 3 oil treaters they had these desanding headers that were inside the pressure envelope of the vessels. And as you can see in the top left-hand corner, the fabricator didn't use standard flanges. They manufactured some plate, and they made these plate flanges, had just gotten terribly corroded, and they were getting leaks and whatnot, and it was causing some efficiency issues with the inside the vessel with desanding and dewatering. So the client, this was a critical path project. The client had 3 vessels, a total of 30 flanges inside confined space. They had a massive critical path schedule. This project of replacing these 30 flanges was 3 weeks in their plan, massive cleaning, steaming, and degassing of the vessels, confined space, breathing air for the welders, man watches. You can imagine the entire requirement for confined space welding and cutting. They also had a big concern with arc strikes as they were trying to remove the flanges and to do the welding. So we originally, they had more than 180 schedule hours, 500 plus man hours planned in this job, and sorry, I'm just turning on my video here. I forgot that I didn't have it on. We looked at this project, and this was before we had CRNs, but this project, because these flanges were inside the pressure envelope, didn't require CRNs. We were able to go into this vessel with cold work. We cold cut these flanges off, fit it. We removed and installed each flange in about 25 minutes. And the entire project to replace these 30 flanges was 2.5 shifts. And so there was a massive, significant savings in terms of time, in terms of safety, and in terms of cost. The client didn't share what a 3-week welding project in confined space was, but surely it was in the hundreds of thousands of dollars, and we were a fraction of that cost. So this is a SAGD example. Now this is a different example I'm going to share with you next. See if I can. This is a fire water system at the Peter Lougheed Hospital in Calgary. And this is a utility room that is on an active hospital ward. This room was literally 12 feet away from the nursing station and on an active ward with patients in the ward. They needed to install an isolation valve because the way their fire water system had been designed, they had no isolation across multiple floors to be able to do any changes or any rerouting. And they wanted to install this valve in this fire water system. We went into this job on a night shift with 2 technicians. We performed a freeze plug on the top and bottom of the tie point location. After the freeze plugs were established with liquid nitrogen, we were able to cold cut out the initial spool, and then we fitted the first 2 quick flanges on either end of the open-ended pipe. We then took the pipe that we had cut out, and we fabricated a new pup piece spool with 2 more quick flanges, and we installed the valve, installed the spool, bolted up the connections, did the hydro test on all 4 of the quick flange connections, and finished that tie point in a 12-hour shift with 2 people in a closet on a live hospital ward. No hot work required. The entire activity was cold. Now here is a third example. This is a refinery in Sarnia, Ontario, and this was an underground 6-inch propane line that the client needed to do a tie-in on. They had a lot of concerns with LELs. They had a major issue, welding concern issue, because of the presence of benzene. And we were able to cut and prep the line, fit the flange, and hydro test, and the entire activity, including the confined space into the trench, or I don't know if you'd call that a trench so much as a hole, was performed, the total activity for everything was 6 hours. So those are 3 examples of work that we've done, and when there's many more examples. But you've got a confined space in a vessel, you've got a utility closet for a fire water, and you've got a propane line with welding benzene issues. All of these were very small crews, integrated crews, what we really call a turnkey cold tie point, leveraging a variety of technologies from cold cutting and freeze plugs and hydro testing, and obviously the headliner of the show being the Quickflange technology. So let's answer any final questions. If we answered a lot of questions throughout the presentation, but we're going to just jump into some Q&A. If you shift from either entering into the Q&A section of the webinar and ask your questions, or if you can't find that button and you want to just answer it in chat, I'm watching both the chat feed and the Q&A if you want to ask a few questions. And we're here to answer, but please don't leave yet. As soon as we finish Q&A, the next slide, I'm going to give you a few links where you can get some more information, or you can learn how to reach out to us if you have applications you want to look at. So hang around if you don't have questions, and if you do have some questions, please throw them out now. This is where we should have the Jeopardy music waiting for the questions to arise. Okay, we've got one question coming in. Any history of failures with Quickflanges, Phil?
Yeah, absolutely. We have had history of failure. Of course, we have. As I mentioned earlier, it's generally at the point it's technician failure or error, should I say? Not failure. That's wrong to use that terminology. But error, where either they have the biggest one I guess we had was on a 10-inch pipe, where the technician cut the pipe so off square it missed the first groove. So although they still tried to install it, naturally it just didn't get the sealing capacity, and we had to just cut the flange off and put a new flange on. As I say, if there's a failure, it's usually captured at the hydro test. But we've had no in-service failures with the flange after it's been installed for a long period of time. The very first flange that we installed back in 2004 was supposed to be in for a temporary and removed, inspected. Funnily enough, it's still in service today. So,
and you know, we've had over 10,000 installations, live installations that are all in service all over the world with almost every major operator that you can think of. And in Canada, we have worked with most of the major operators in one way or another, either in Canada or in some of their overseas applications. So whether that's Exxon or Shell or CNR, as some of the big players, Suncor, we've done those both onshore and offshore for Suncor, as well as many mid-size operators. How heavy, sorry, I'm going to jump ahead. I want to catch the first question first. So the question is, what sort of footprint do you need to run the tool, like the drain on the liquid boot under an inlet separator? So what kinds of space restrictions do we have?
okay. So just to ensure, you can correct me if I've misunderstood. So is it how long or how much straight pipe do we need in order for the tool to run inside the pipe? Is that ultimately what we're really asking there?
I think it's more the length of the tool from where you're fitting the flange to where you might have obstructions in terms of tool length protruding past the raised face.
Yeah, well, I mean, that's fair enough. I mean, each tool, so there's multiple different driver units. Now, when we talk about driver unit, we're talking about the hydraulic cylinder that operates the cone that you saw in the earlier video. So they range in length from, let me see if I can give you some kind of, lengths really might be even better. let's give it to you in inches here. So our smallest tool in length is 13 inches in length. And then our biggest tool, when you move up to the 14 inches, 44 inches. So, you know, you're not talking a massive tool here for any of these components, but ultimately, if you're cutting out a section of pipe, generally it's always going to be longer than the tool that you're putting in to do the activation. So we don't generally have any issues with the length of the tool. What is a consideration and that clients need to think about is if you're working close to elbows or valves, is how much straight pipe you need for the tool to run inside the pipe. And again, that varies, you know, not massively, but straight pipe runs from, you know, you need about 4 inches of pipe up to, even if you go to one of our biggest sizes, you're looking at 12 inches of pipe, so of straight pipe in order for that tool to activate. So again, not huge. We can work in small confined areas as well with the tool. The diameters of the tool are generally, as a general rule of thumb, are never normally bigger than the flange you're installing. So you can think about that. So the diameter of the flange, the tool doesn't normally exceed the diameter of the flange either.
Okay, next question is about tool weight.
Okay, yeah, that's always a question that gets asked. And tool weights, again, they just range anywhere from 9 kilos. And we do have nicknamed, sorry, pounds, 9 pounds, sorry, not kilos, 9 pounds. We have our code name Big Bertha, which is 1,100 pounds, but that's an extreme. So generally our heaviest tool is around about 385 pounds, which of course, if you're working with 8-inch or 12-inch pipe, you're probably going to have rigging in situ for that anyway. But we have all the data sheets with all that information I've just talked about that we can share with you all. So
Yeah, if you
Don
reach
and my
out
team
with some of the links after on the next slide, we can send you flange and tool data sheets with lengths, weights, sizing of the flanges. We've got some great reference tools that you can use. Next question. I'm looking at this. Any catch points in a connection that would stop PIG or inline inspection tool from going through? This is from James in Ontario. I believe he works on the pipeline side with the client.
Yeah, none whatsoever. So there's no restrictions, there's no intrusions. Actually, the root penetration bead of a weld is more severe for doing pigging than a Quickflange. So no, there's no restrictions and no issues there whatsoever.
Got a question here on how good is it for cyclic stress, thermal cyclic stress?
Yeah, I mean, I guess that's an open-ended question, which would be difficult for me to give you exact parameters. If you had cyclic stress conditions or you had something specifically on the line that you have the detail on, we would ask for you to give us that detail, and our engineering team would evaluate that. I know that sounds like a politician's answer there, right there, but I can't give you a defined answer there until we knew what we would be talking about. You know, thermal cyclic conditions, what I can tell you is if you were talking about putting it into a situation where it was going to see 205 degrees Celsius and negative 50 degrees Celsius, and it was to happen instantly and happen a lot of the time, we would maybe have concerns there, and we might be a recommendation that maybe it's not the right situation for that connector. But as I say, we would take that on a case-by-case basis, and we would evaluate that based on your design criteria for that line, and we'd capture that on the application form. Which, again, sorry, I haven't given you a detailed or the exact answer there, but it's kind of there's lots of variance, I guess, to give a detailed answer on that one.
Thanks, Phil. The next question is on, are there any material type restrictions? Is there any material you've come across that has been a non-starter? I believe there's one that we came across a while ago that just didn't have the right properties, right?
Yeah, I mean, we've been asked for copper before, and of course, copper doesn't have the strength in the pipe to be able to work with the style of technology. The one that we've been asked for, and it's more, again, in certain offshore installations, is titanium. The issue with titanium pipe is that it's so inconsistent with the material that wanting 10 when we've done numerous amounts of tests on titanium, just so you know. God knows how many thousands or tens of thousands of dollars we spent on it. But titanium wants to crack 1 in 10 applications. So it's just, there's not the consistency there. So I would say titanium, copper is probably the two that we have been asked for a few times that we just can't do.
Does that mean we can't do quick flanges in the whiskey stills in Aberdeen?
Well, it's funny. They're moving into stainless steel in the whiskey stills now. So copper's moving away and they're moving into stainless. So the answer is, yeah, we're looking to work in actually the whiskey stills.
You know, you made a comment about the temperatures in Scotland not being as harsh as the ones in Canada, and I own a flat in Aberdeen. My wife is from there, and I beg to differ.
Yeah.
I don't see any more questions, folks. If you have any last questions, throw them on here now. If not, I'm going to move to the next slide and give you a few links that you can go to, how you can reach out, how you can grab some information. We got anything else? Lots of thank yous, I think. I think we're good. All right, so that's the end of the questions, folks. I'm going to go to our last slide and give you a few links that you can grab. We have a quick at-a-glance PDF that you can grab. You can join a short 5-series email series that we have on Quickflange that'll give you, we'll dive in with more content, more testing data, more white papers that you can have. So you can go to a few different places. If you go to our website at innovatorind.com and click any of the buttons that say want to talk, fill in your name and click the box that says weldless connections. If you have an application or you have some questions and you click weldless connections, then we'll be able to engage with you there. That's where we'll share with you some data or collect data sheets from you. One of the I think it was Dan who had mentioned earlier, do you have to fill out a data sheet for every installation? I would say for us as a service contractor, we often will take your drawings and your normal packages and we'll extract and prepare most of those documents. And if there's any gaps in our understanding from those tie points, we'll go back to you and say, hey, we're missing a particular pipe schedule or something. But a lot of the time we'll be extracting a lot of the data off of your data sheets and then just getting you to confirm and sign off on them. So we do our best to make this as administratively simple for you as possible. If you want to grab a 1-page Quickflange data sheet to be able to share with your colleagues, you can go to info.innovatorind.com /quickflange-info. So that's this link right here. And if you simply go to our website at innovator.ca and in the services section, you click on weldless connections or Quickflange, you'll also be able to grab that information. And Wyatt, my partner in the background, has just shared the link for grabbing the quick 1-page PDF. Or you can go to our website and click Want to Talk. Click on that box and ask us some questions. If you have some jobs, the big thing I always say to clients relative to Quickflange is if you have candidates where you would like to be able to consider eliminating hot work, or you want to look at some candidates where you think you could leverage Quickflange, just reach out to us and we'll work with you to figure out what are the best places to use it. And again, think about it in terms of total elimination of hot work, an integrated crew where we can work with you to do the cold cut, prep the pipe, install the Quickflanges, do the hydro test, and even fit up and do the technical bolt up. And for anyone who's a general contractor, we will partner with you on this. We can train your people. We can put one of our people with your team and work in an integrated way to make this as efficient as possible. Innovator's strategy with leveraging technology is to optimize the crew size to make it as small a footprint as possible so that you're just getting orders of magnitude of productivity and cost and time savings by not having too many different people interface with it, with a tie point. So the possibilities are sort of endless in terms of how you can drive efficiency, improve safety, improve productivity by leveraging Quickflange technology into your tie point plan in some or many applications. And if that is no more questions, folks, so I wanted to thank you all for coming. This was a great presentation. Phil, always a pleasure, my friend. I want to thank you for joining us all the way from Aberdeen, Scotland. And you know, we, other than that one glitch, the tin cans and the string kept kept tight, and we were able to stay connected the whole time. So the amazement of technology. Okay, folks, thank you for coming.
Thanks,
I
Tom.
really appreciate you all giving us your time. And please, in a couple of weeks, we have another webinar coming up on how you can leverage engineered composite pipe repair in repairing your piping systems that you're not going to be working on. So, you know, we all have a lot of budget restrictions right now, and we need to find ways to extend the life of our piping systems, to potentially deal with the scopes of work that have been removed from our budgets for this next year while we're facing COVID and lockdown and a big crunch on oil. So in a couple of weeks, we have another webinar, and we're going to be focusing on pipe repair using engineered composite design. And so that is, you can register for that by going to innovatorind.com/technorap-webinar, or you can go to our website and click on the webinar button, and you'll be able to find those future webinars. So really appreciate everyone joining us today, and that'll be a wrap for today. And we'll see you all next time. Thank you very much.
Yep, thank you.